Greetings, everybody. I am going to pick up with laws of exponents. I am on page 4 of the notes. The blank copy and the key are available on Schoology. If you go into the Unit 9 folder, they are right there up top. Feel free to print this off, write stuff down, and follow along if you would like. You can take your own notes or you can just watch. You need to decide what you need to do to learn the material. So whatever that looks like for you, that's what you need to do. Let's briefly review one of the products we ended with last time. Last time we talked a little bit about power raised to powers, and I'll look at these last few try questions right here as a little bit of a reminder for how to do that. So power raised to a power, we multiply the powers, and remember the reason is because if looking at this problem right here, if we were to expand this out, it's like 3 to the 6th cubed, which is 3 to the 6th multiplied by itself 3 times. Now thinking back to our multiplication property, which is the first one that we learned in this unit, we did that a couple days ago. Remember, when you multiply, you keep the base and you add the powers. So that's 3 to the 18th power, 6 plus 6 plus 6. Now you may notice that with the 6 and 3 right here, you could just multiply those together right off the bat to get 3 to the 18th. So that's our rule. When you have a power raised to the power, you keep the base and multiply the powers. Notice that a problem like the one we just did right here is different than a problem like this, 3 to the 6th times 3 to the 3rd. These are different questions. The answer to this question would be 3 to the 9th. 6 plus 3 is 9. 3 to the 6th raised to the 3rd, you multiply the power. 6 times 3 equals 18. So just notice the distinction between those properties. Now, today we're going to get more into power of a product. Well, let's break down that statement right there. A product is two terms being multiplied, and they are raised to a power. So that's what we're doing today. So instead of just raising one exponent to a power, we have two. So for example, in this question right here, we have c squared and d to the 3rd. They're being squared. So I want you to think about this square right here applying to the c and applying to the d. It's like two mini problems. So if you have c squared raised to the 2nd, it's c to the 4th, 2 times 2. If you have d cubed raised to the 2nd, it's d to the 3 times 2, which is 6. So you're keeping the base, c and d, and you're multiplying the powers. 2 times 2 to get 4, 3 times 2 to get 6. Let's take a look at this one. Maybe you could pause the video and try this and then resume the playback. So for this one, I'm going to highlight. You have your m and you have your n, two different problems, and they're raised to the 3rd power. So that 3rd power gets applied to the m and the n. So that's m to the 2 times 3, which is 6, and n to the 4 times 3, which is 12. That would be your answer for that one. So generally here, our property, our general rule for xy to the n is x to the n, y to the n. Both exponents or bases get raised to the power. So raise each base to the power. Try those examples on the bottom, pause this video, and then resume it to see the answers. Here are the solutions to those examples on the bottom. This one was just like the examples we did. You just multiply 4 times 2 to get 8, 3 times 2 to get 6. Now, what about this one's a little different. I imagine some of you may have missed this one. Here's the key. M is really m to the 1st power. So when we're simplifying m to the 1st raised to the 3rd, 1 times 3 gives us 3. That's how we get m to the 3rd. And n to the 5th raised to the 3rd gives us 15. So that's how we get that. Now notice how we could have bases that are variables like m and n, and then here we could have bases that are integers like 4 and 5. So here, again, you keep the base does not change, 4 and 5, but then you have 3 times 3, which is 9, 2 times 3, which is 6. Same property, keep the base, multiply the powers. Okay, we are on to page 5 of the notes. Again, feel free to try any of these problems up here. These are great practice questions. Feel free to do them. Check the answer key to see how you did. I'm going to go ahead and move on to division. But like I said, if you need extra practice, that's why we have that built into the packet there. So take advantage of that if you need it. Next, we're going to talk about division. So, division of exponents. Let's frame this in context of just the most basic kind of division we know of, which is fractions. You guys have dealt with fractions for a long time. Think about something like 6/8. If I said it's time to reduce 6/8, think about how you really are doing that, right? 6 is the same as 2 times 3. 8 is the same as 2 times 2 times 2. So you're breaking down those numbers into factors. Now look at this. Think about what is 2 divided by 2? Well, it's 1. So it really just kind of cancels out is what happens there. Those 2's just really cancel out, and you're just left with 3 over 2 times 2, which is 3/4. So we're canceling common factors there to do that. How would that look in context of an exponent like here in number 2? 7 to the 5th power divided by 7 to the 2nd power. Let's expand that out, just like we did that fraction above. Let's expand it out and cancel. So if we were to do that, 7 to the 5th power is 7 times 7 times 7 times 7 times 7 divided by 7 squared, which is 7 times 7. Now, just like we were able to cancel the 2's when we were reducing 6/8, we can cancel 7's here, because look at this. We got 7 over 7 here, and we have 7 over 7 here. Those cancel to a 1, right? So they essentially just are canceled out, and we're left with how many 7's up here? 3. What's another way of representing 7 times 7 times 7? 7 to the 3rd power. So our answer is 7 to the 3rd power. All right, well, you may be wondering, well, how could I get there right off the bat? Well, take a look at 5 and 2 and ask yourself, what can you do with 5 and 2 to get 3? Keep thinking about that. What if we expanded out x to the 5th over x to the 3rd? Let's try that one. Well, again, it would be x times x times x times x times x over x to the 3rd, which is x times x times x. All right, look what we got here. All those x's are going to cancel each other out, because when you divide something by itself, it equals 1. How many x's are you left with? 2. So your solution is x squared. Okay, time for the same exercise as last time. What can you do with 5 and 3 to get 2? Keep thinking. I think some of you probably have it. Number 4, let's do another example, and then we'll just write down the rule to help solidify this for ourselves. All right, m to the 4th n squared. So that's m times m times m times m times n times n all over m times n times n. All right, well, I got some m's here that are going to cancel out, and then I have some n's here that are going to cancel out. So all I'm left with here is just 2 m's up top. So my answer to this is just going to be m squared. M times m is m squared. Okay, one more time here. What can I do with 4 and 2 to get 2? There's no n's in my solution. I don't see any n's there. There's no n's. This is really like a you know what? I made an error up here that I just realized. Let's see, anyone see the error? This just says n down here. It's not n squared, but what did I write over here? Down here I wrote n times n. That was incorrect. So I need to go over here and erase one of these n's. That changes things a little bit now, doesn't it? Because now there is an n remaining up top there, isn't there? So in my final answer, I will have an n remaining. Okay, back to what I was saying before. So this is really like an n to the 1st down here. And what can you do with 2 and 1 to get n to the 1st, which is really what's down here? This is n to the 1st. What can you do with 2 and 1 to get a 1? Okay, well hopefully you have it at this point. Hopefully you're figuring this out. A to the m over a to the n, as you've probably seen now through our examples, we keep the base when we divide exponents with the same base, but what do we do with the powers? What did we do with the powers? We subtracted them. So a to the m minus n is your general rule. So in the blanks there we could say keep the base and subtract exponents of like bases. Let's do some examples here. On the bottom, 8 to the 10th over 8 to the 7th is 8 to the 10 minus 7, right? We have to subtract the powers, so your answer would be 8 to the 3rd. If we have 4 to the 11th over 4 to the 5th, that's going to be 4 to the 11 minus 5, which is 4 to the 6th. And d to the 20th over d to the 13th is d to the 20 minus 13, which is d to the 7th. Why don't you guys try the got it examples right below and then resume the video once you've tried them. Okay, here's the two got it examples below. Did you get 9 to the 12th for the first one? 35 minus 23 equals 12. That's how we get that. Keep the base, subtract the powers. What about this got it over here? A to the 12th over a to the 8th is a to the 12 minus 8, which is 4. Okay, so a to the 4th is what we get from this one. What about a to the 6th over a squared? Well, a to the 6 minus 2 is also a to the 4th. Interesting. So are they equal? Yes, they are equal. I just have two more problems I want to do with you, but as was the case with the previous property that we learned about powers of products, there was extra practice built in. There's extra practice built in here for division too. So check out the answer key, check out the notes, get that extra practice if you need it. Let's hone in on these two examples right here. M to the 5th, n to the 6th, r to the 3rd over m squared, n to the 5th, r to the 3rd. I want you to think of this almost as three separate questions. I'm going to divide this up like this so that you can think of this as one problem here with the m's, one problem here with the n's, and one problem here with the r's. So you're just going to approach it like that. You're going to do one little question at a time. Well, what's m to the 5th over m to the 2nd? Well, that would be m to the 5 minus 2, so that's going to give me 3. And then I'm going to write my n and my r. I got to figure out what's going to go up here and what's going to go up here still. Well, let's figure that out. N to the 6 minus 5, that's 1, so that's what goes there. And then for the r's, 3 minus 3 is actually 0, isn't it? So this is r to the 0. Now, one thing we're going to learn next week is that anything raised to the 0 power equals 1. So r to the 0 actually just equals 1, okay? But for now, let's just leave it like that. This can be our answer, okay, for now. But we're going to learn more about 0 exponents and negative exponents coming down the chute next week. So let's check out this last problem here. All right, so again, I'm going to divide it up. I'm going to divide my m's and my n's. So I have m's over here and I have n's over here. Okay, so I'm going to kind of look at them as two separate questions. So I have m to the 8th divided by m to the something that has to equal m to the 6th. Well, let's think about the property. The property says that when you divide, you keep the base and subtract the powers. So 8 minus something has to equal 6. What is that something? That something would have to be a 2, wouldn't it? Because 8 minus 2 gives you 6. What about for n? Well, n to the something over n to the 5th, so something minus 5 has to equal 2. What minus 5 equals 2? 7 minus 5 equals 2. So that other blank would be a 7. Okay, boys and girls, that's it for the lesson today. Please see Schoology for additional practice. There will be some kind of progress check in Schoology in addition to any other practice that we decided to throw in there. So please take a look at that and stay on top of your work and schedule a conference if you need anything. We miss you guys. Hope to see you soon in a conference. Be well.